has a different topic. Tonight's topic is going to be the graph questions or the data interpretation questions. And a lot of the problems that we are going to use tonight come from this book. That's a book that we write. It is probably actually more than 5 pounds now. It is a large book, and it's a great resource if you are just looking for a big companion of practice problems. It's divided by topics, so you can say, you know, I want to do more practice with ratios, and there's a chapter that's just like a couple dozen ratio problems. So good book to have, particularly as you get deeper into study. We'll see some problems from it tonight. So we're going to start tonight by talking about just, you know, what are the graph questions? What do they look like? Where do they show up? Foundations of that. We're going to talk a little bit about reading graphs and some of the tricks that they like to play in these graphs. And then the big focus of tonight is I want you all to leave tonight's session with a really consistent, strong process for approaching these graph questions. One of my big goals in the GRE classes that I teach is to make sure that all of my students, no matter what type of question they see, no matter what difficulty it is, they know that they have a process for that question. They can be really consistent and methodical, and over time become very efficient and accurate by doing that. So tonight we're really going to emphasize process and consistency in how we look at these graph questions. So for people who are newer to the GRE, and maybe a nice refresher for people who aren't, every quant question, there's 2 quant questions that are scored on the test. They have 20 questions each, and you have 35 minutes to do those. So you have to move pretty fast when it comes to these. Little under 2 minutes. And we'll talk a little bit more about timing in a second. You're going to see 3 different types of questions. You're going to see quantitative comparison questions that look like this. You have 2 quantities and you have to say which is bigger. Are they equal? Can you not tell? We've done some workshops in the past specifically on this question type. So if you kind of go through our YouTube channel, you can find more stuff that might be helpful with those. We won't talk about them tonight. Half the section are sort of normal, what we call discrete quant or non-QC. Those are your sort of A, B, C, D, E multiple choice that are probably a little bit more like math that you've done before in school or on the SAT. And then the third type is what we're going to talk about tonight. It's going to be our focus, what we call data interpretation. And these are 3 questions that ask you about a graph or a pair of graphs. Now, when we think about the structure of a quant section, you're going to see the same pattern in each section. You're going to start out with the QC questions. So you're going to have those 7 of them, those comparison questions up front. And these are actually going to be a little bit faster. You're going to do these in about 1 minute, 15 seconds. Probably not going to be doing them that fast when you first start learning them, so that's okay. But over time, the goal is to make these very efficient. Then you'll get 5 of what, you know, we call non-QC, just sort of the regular old multiple choice questions. And those are going to take about 2 minutes each. Then you get your 3 graph questions. And those also take about 2 minutes each. And then we come back and we get our 5, the other half of the non-QC questions. 2 minutes each. So the graph questions that we're going to talk about tonight, they come a little bit later in the section. They can also sometimes be a little more time consuming. We'll talk about why that is. So just one thing that's very important is making sure that you get to that point in the section without being too far behind time, so you just have enough time to work on these. Any sort of format structure questions? All right, so far so good. So let's get into graphs. The graphs that are on the screen, these are a couple sample graphs we're going to do some warm-up problems with. The bad news is that the graphs in the GRE are never going to be this simple. It would be nice if they were, they're not. One of the big challenges with graph questions is that you get a lot of extra information. These graphs are very dense. There's a lot to process. Just out of curiosity, where else on the GRE do we have to deal with that, where we get like a ton of extra information and it's really dense and kind of boring to sift through? Like, does that remind anyone of another part of the GRE where we're going to get like way more details than we need? Yeah, Tanya, I very much agree with that. Yeah, Jesse, good. Yeah, good instincts, guys. These are very similar to reading comp. So actually, sometimes people who sort of prefer verbal or feel like they have a little more comfort in verbal, find that these graph questions are a part of quant that can be a strength for them, because it is testing very similar skills. Like, can you get a bunch of information and sort of quickly figure out how to extract what you need from it? So it might help to think of these as reading questions, especially if you're someone who doesn't feel as confident about math. For me, I'm very much a verbal person, so I love this question type. One thing that is very, very important and that we're going to harp on a lot is just always be very clear on the question you're asking. And we'll come back to that when we look at our process. The other little fact that's good to know about these is these are drawn to scale. So if you've done any work with GRE geometry, you know that there we get shapes that are kind of trying to mess us up. They're not proportionate, but here that's not true. So if I even took away these labels on my circle graph here, I could still be confident that Q4 had the most sales because it's the biggest wedge. And I can sometimes use, in a pinch, if I'm a little stuck, I can use just some quick visual estimation to make a reasonable guess on a problem. And that can be a nice thing about these two. All right. So I think we should just try one. Let's just try a little warm-up one. Let's see how it goes. I'm going to give you maybe a minute and a half, minute 45 to work on this. If you get an answer, awesome, but don't share it yet. I'll ask you all to share your answers at the end of time. So here you go. Oh, let's start with this one, actually. Here you go. Try it out. I'll set a timer, and then we'll see how it goes. All right. You can now go ahead, chat your answer into the chat if you have one. Cool. I like it. We're coalescing around two answers, and I feel really good about that because one of these is right and one of these is the big trap or trick answer. So we're all getting close, and we're going to get to learn about a fun trap. So here are my two answers. What language in this question is really important here that might help us identify what the trap is? When you looked at this question, was there anything you're like, oh, that's something I need to sort of be careful of or pay attention to? Yeah, nice, Iman. We have percent increase. Now, as soon as I see language that has to do with percents and increase, and that can be percent increase, it can be percent greater than, it can be percent less than, percent decrease, what formula do I immediately want to think of? Like, how is this different from a question that asks percent of? Yeah, on it, Iman. Like it. We need to think about the percent change formula. And that, if anyone needs a refresher, is going to be change over original times 100. There's other ways to set it up too. You could set it up as a proportion. There's lots of ways to calculate percents, and they work well for different people. This is the one that I personally like. So if I'm dealing with 2010 to 2012, I'd say like, okay, 2012 is 5, 2010 is 2. The difference between those is 3. My starting here is 2010, and then I'm going to get 150%. And that's going to be my correct answer, which a lot of people got to, which is awesome. How would I get to D? What mistake would I make that would get me answer D? I love when people make mistakes because we always get to learn something useful. So what's the mistake that get us to D? Yeah, yep, Jesse, that's definitely the trap in this problem. If you just do percent of, you'll get D. And the GRE loves this trick. It's one of the reasons we're looking at this problem. And so I'm glad people did choose D, because now we see, okay, if we're dealing with percents, we need to be really alert to whether we're dealing with percent change or percent of. I guarantee if a question asks for percent change, there's going to be an answer that's actually percent of. There to trick you. All right, let's try another one. So that's one little thing to pay attention to in data interpretation. Let's try another one to warm up. Here you go. I'll give you maybe about the same amount of time. We'll see how it goes. All right, everyone chat in your answer to this one. And I'd also like you to tell me what answer you choose, and then tell me, did you use a calculator? Lots of people use calculators. Cool. So what do I plug into my calculator if I'm going to solve this with a calculator? What numbers do I punch in? Yeah, nice. Yep. remembering it, we have 1.2 million, so I want to add in those zeros like this, and then I just multiply that by 0.18. I convert my percent for quarter 1 into a decimal, and I get 216,000. When I do that, and that's answer D. Lots of people were getting to. Being really careful about the zeros. I think that's a common mistake in this problem, is just maybe to drop one of the zeros off of the 1.2 million. So being very careful about that. Did anyone not use a calculator? I'm curious about that. And if you didn't, how did you do it? Or how did you decide, well, I actually don't need to use a calculator? I'll actually open this question up to everyone. Even if you did use a calculator, maybe take a look at the problem and think about, why don't we need to use a calculator here? Because I actually wouldn't use a calculator to do this problem. Why is that? What is it about this problem that means I don't have to use a calculator? Yeah. Yep, Tanya, that makes total sense. And what is it about these answers? Like when you look at the answer choices, what do you see that allows you to do that kind of rough estimation that you did, Tanya? Because I think what you described totally makes sense to me. Like, what's interesting about these answer choices that tells me, like, oh, I don't have to be precise at all? Yeah, exactly, Maria. I can use sort of my tip calculation technique, and we'll walk through that in a second. Yep, that's a good way to do it. So this is a really important thing about all of GRE Quant, actually. This is maybe the biggest important thing I have to tell you today, which is always look at the answers before you start solving. Because the answers are going to tell you a lot of stuff that's useful about how you want to approach the problem. And this is true for every type of quant problem, not just for graphs. In graph questions, I often look at my answers and I ask, are they far apart? Because if they're far apart, I can estimate. Yeah, these are all good at Jesse. That's a good estimation strategy. Iman, that's a good estimation strategy. Yeah, there's a lot of different ways to estimate here. The important thing is to notice that I can, to say like, oh, these answer choices are just different powers of 10. It's all about the numbers of zeros. So I don't have to plug things into my calculator and be super precise. I can actually just estimate. And there's a bunch of different ways to do that. One way that we'll look at quickly is just the sort of tip calculation. If you want to give a 20% tip, oh, that's just 2 times 10%. And 10% of something is just moving the decimal. So, if I had 102 and I want 10% of that, I'm just going to take my decimal and I'm going to move it over. So here I'd say, okay, if I have this, I'm going to move my decimal over. And then I had 120,000, so that's 10%. And then multiply that by 2, and I get 240,000. So it's not exactly precise, but it's enough to choose that D is correct, because I see, oh, it's in the 100,000 range here. Why might we want to avoid using the calculator on the GRE? Anyone who's maybe taken a practice test or an official test, why is it good to not rely on the calculator if we don't have to? Yeah. Yep, you're clicking on it with your mouse. It takes time. It's easy to add little mistakes with the calculator. Actually, I often see people make calculation errors with the calculator because I think we think calculators are going to be really accurate, and there's still a lot of room for human error. So in data interpretation, if you see answers that are far apart, think about estimating. And if you don't feel super comfortable with estimation stuff, just practice it. Walking around, you see a license plate, be like, what's 20% of that? What's 15% of that? See if you can do these estimations quickly. So that's a warm up with a couple simpler problems to illustrate some of the sort of core mechanics of these questions. I now want to start looking at some more complicated graphs. And to do that, I want to talk about a process. Is anyone else having issues hearing me? Okay. I'm sorry, Andrea, it might be your connection. You could maybe turn off the video or minimize the video. That might make it a little bit smoother. Okay. So we're going to now get into our process for DI. First thing, it may sound really basic, but the first thing when you get these questions, you want to take a moment to read the graph and understand the graph. It's like with reading comp, you want to read the passage because you're going to be asked multiple questions about the graph or graphs. So you want to make sure you understand them up front. If you get confused about the graph on question 1, that's 3 questions that you could miss out on. When I read the graph, there are a few different things that I consider. First, I read the title. Maybe seems really obvious, but I find that people often skip over it, and there's a lot of useful information in titles. Next, I consider the type of graph, because the type of graph tells me about the kind of information that the GRE is going to be presenting. Like we choose a type of graph to convey a certain type of information. So for example, if I get a pie chart, what is a pie chart telling me? Like why would we use a pie chart? Why would I, take a set of data and organize it into a pie chart? Yeah, parts of a whole. So right off the bat, I'm thinking, okay, what are my parts? What's my whole? I probably have percents involved. What about a bar graph? Why do we use a bar graph? What does that tell us about the data? Or why would we organize data into a bar graph? Yeah, we might talk about change over time. We might also be talking about relative amounts if we're dealing with different categories instead of different timelines. Cool. So we're comparing the overall totals of different things. What about something like this? What about a stacked bar graph? Where I have different bars, but then each of those bars is being split up into different components. Why would I put data in that? Yeah, it's like a pie chart plus a bar graph. Exactly. Like I'm going to know about sort of relative totals, and I'm also going to know breakdowns within categories. Cool. We're going to look at a couple of problems with stacked bar graphs in a second. After that, I look at the axes and the units. Am I dealing with millions or hundreds? Do I have percents? Do I have actual numbers? I make sure I'm very clear on what sort of measurement I'm using. And then the final thing that I'm going to do, particularly if a graph is very tricky or complicated, I'm going to pick one point on the graph, and I'm just going to tell myself, okay, this bar says that, 10% of people like cake. That is a really unrealistic statistic. I think lots of people like cake. If I can understand and explain one point, I understand the whole graph, but I get to that understanding without having to look at, this massive information. Like I'm focused, but I also can trust that I really understand the graph. So let's try out this first step. I'm going to give you guys a graph, and I'm going to ask you in the chat to explain one part of the graph. So I want everyone to chat in, what does this chunk of the graph tell us? Cool. Got a couple answers. Do you guys agree with what Jesse and Maria are saying? And just give a +1 if you're like, yep, I agree. Yeah, nice. these lines are Brand Smart, so this is the number of boxes of Brand Smart sold at store one. Awesome. So we understand this graph. We're feeling good about it. The next thing that I'm going to look at is the question. So I understand my graph. Now I'm going to go and I'm going to look at the question stem and I'm going to read it. And what I want to do after I've read it is I want to break it down. I want to figure out what am I going to need to know to calculate this. I'll show you an example of what I mean. If I asked you what % of dogs are blue, well, to calculate this, you'd say, okay, I need the number of blue dogs, and I'm going to divide that by the number of dogs total. And I would actually write something like this down on my paper because these questions are very dense, they're very complicated, there's a lot of details. I want to be very clear on where I'm going, and I want to have that written down so that I can come back to it as I work through the problem. It can be really easy to do a lot of things right, but then just make a small error about what you're solving for and run into trouble. So I have this very clearly unpacked before I start trying to do my calculations. Rushing into calculations is often a big source of error on these problems. So let's try that. Here's a question, and I want everyone to chat in. What do you need to calculate this? Like, break this question down into like this and this. What are the things we need? Cool. Iman and Maria. Do you guys agree with what Iman and Maria are saying? Yeah. Yep. To find this ratio, I'm going to need some actual numbers. Like often to calculate a ratio percent, I do need to pull some actual numbers from my graph. So I'm going to need the number of boxes of Brand Smart at store 2. And what's the ratio of that to the number of Brand Smart boxes at 4? And I need just the number of boxes, pulling that off the graph. One thing to remember, we're not going to talk a ton about ratios, but because we are dealing with them here, I can also write ratios as fractions. So this would be another way that you might see that same ratio written. The GRE uses both the colon format and the fraction format when it deals with ratios. All right, so I've understood my graph. I've broken down the question. The third thing I do is I look at the answer choices and I say, okay, do I need to be precise here? Are these answer choices close together? Should I be really accurate, bring in a calculator maybe? Or are these answers really far apart? Can I estimate? So here are the answer choices for the problem that we've been looking at. What do you guys think? Can we use like really rough estimation? Should we be kind of precise? Everyone make a vote, like precise or loose estimation. Yeah, what are you guys seeing that you're like, I should be precise here? What is it about these answers that makes us think? Because I agree, I think we should be precise. Yeah, I have specific fractions or ratios. Yeah, and they're pretty close together. Like when I think about this decision, I think about the grouping and I'm like, 3/4, 5/6, they're not that far apart. You know, if it was like a half and 7 halves, and these were really disparate fractions, then I might be able to be kind of loose in my calculation. But here I see they're pretty close together. Now I think we're ready. We've understood the graph, we've understood the question, we know how we're going to approach our calculation. Now I can actually go into the graph, pull out the information, and solve. So let's put the pieces all together. Here's the whole problem. Give you a minute or so to work on it, and then I'll ask you guys to chat in your answers. All right, go ahead if you have an answer. What answer did you get? If you're still working, keep working. If you're stuck, you can just answer with a question mark. You're like, I started out and something went a little awry. All right, cool. Sandy, Brigitte, where are you guys getting stuck? Is there a particular place where you're like, ooh, this was trickier than I expected? I'm going to start. I know that I'm comparing Brand Smart and Stores 2 and Stores 4. So I'm just going to kind of block out the things that we don't need, Stores 1 and Stores 3. And I just need to focus on Brand Smart. And I know, okay, Brand Smart starts here. And let's say that's, if this is 40, 45, that looks like it starts around 46. And then it ends around 66. So I think there's about 20 boxes in that range. That's how I get the number there. And remembering, I'm looking for Brand Smart Store 2 in relation to Brand Smart Store 4. So I have 20 boxes for Store 2. And then I do the same thing. What numbers did you get for this? Let's say I'm starting 30. Let's say that's 33. And that's maybe 68. Yeah, I get around 35. And now I see, okay, this doesn't match my answers, right? Like I like these numbers. I could write it this way, 20 over 35. What do I need to do? If I get something like this and I don't have any answers that are 20 over 35. Yeah, I need to reduce my fraction. So if you do the math and you don't get the right, you don't get something that matches your answer, think about, can you reduce it? Can you change the form? And when I divide both by 5, I get 4 over 7. What if I'd estimated this differently? Like, what if I'd said this was 67 and I'd gotten 20 to 34? What should I have done there? Cool. Glad it's clear now, Brigitte. And Sandy, yay. Yeah, nice. I can then say, this question starts off with the word approximately. So I know that there's like a little bit of wiggle room here. So if I get 20 to 34 and I'm like, almost both multiples of 5, then I'll just say like, okay, let me revise my estimation. So we sometimes have to kind of tweak a little bit, particularly with graphs like this, where it's hard to read them totally precisely so that we get something we can reduce. All right. Let's do another question with the same graph. And I'm just going to throw you guys into this. I'm going to give you 2 minutes. See how it goes. All right. If you have an answer, go ahead and share it. If you are stuck, put a question mark and maybe a word about where you're stuck. If you're like, feel like you're getting there, but you're still working, take another minute. All right, we have a pretty good consensus. I like it. Yeah. So we have a percentage here. We need to know, we're looking at store 3, and we need to say like, okay, Happy Jacks would represent what percent of the number of boxes sold at store 3? For some reason, my pen broke down there. So I'm going to need what? I'm going to need the number of boxes of Happy Jacks over the number of boxes total. So I'm going to go to store 3. I'm going to say, okay, Happy Jacks, let's say that starts at 22 and it ends at 32. So I have 10 boxes. Is that right? Do you guys agree? Is 10 what should go on my numerator here? Yep. This is the twist. I have another. So I know that the number of boxes of Happy Jacks doubled. So I have 10 this quarter. I read my graph correctly, but now I'm going to multiply this by 2 because it's doubling. So I get 20 boxes of Happy Jacks. Yeah, and then I see here, this is maybe like 56, 57. Is that what goes on my denominator though? Is 56 the total number of boxes next quarter? Why not, Sandy? What do I need to do? Yeah. Yep. So here yep. So here I'm saying, okay, if I have 56 boxes here, I'm doubling this, right? So I have 10 and then I'm adding another 10. So my total is going to have 10 added as well. So I'm going to go up to 66. Something like that. I would estimate this is probably 56 or 57 because I see this is 55 in between 50 and 60. And now I look at my answers and my answers are pretty far apart. They're going up by 10. And I can look at 20 over 66 and be like, oh, that's almost a third. And I know that 1/3 equals 33%. So I can go close to that with 30%. But this is a good example of a place where I want to read the graph carefully, but then I don't actually have to pull out my calculator. I can, again, kind of approximate because of my answers. All right. Feeling good on this one? Questions? Okay, let's switch. If you get 35%, should you round up? I think if I got 35%, I would probably go back and like double check my numbers and see if I could be a little more precise and get either below or above. Because just looking, or yeah, just looking at 35%, I wouldn't know if I should go down or up. Then that's probably where you'd want to go and think it through a little bit. It's a good question, Jesse. All right, let's try a different graph now. Here's something new. And this next problem is going to be fun because we're actually going to have a pair of graphs. And you do see that sometimes on data interpretation questions. Instead of getting one graph, you get two. Something to know when we're dealing with pairs of graphs. Each question, you'll probably get one question that asks about both graphs, but some of the questions might only ask about one graph. So in working on this next problem, you're also going to need to think a little bit about which graph are you going to use? Is it going to be both? Is it going to be just one? I'm going to give you guys a little bit of extra time, I think, to work on this because there's a new twist to it. So I'll give you maybe 2.5 minutes. Here you go. All right. If you have an answer, chat it in. which graph do we need to use here? The top graph, the circle graph, or the bottom graph, the bar graph? Yeah, yep, exactly. So we look at this question, we say, okay, we want the ratio of people with an associate's degree to the ratio of people with some college and no degree. So I'm going to look at my graph, my circle graph, because that tells me about sort of how many people are in each of these categories. And I'm looking for associate's degree, which is here, to some college, no degree. Cool. And I note here I have percents, but I also have a total. So if I needed to know exactly how many people were in each of these categories, I could calculate it. Do I need to do that here, though? Do I need to say, okay, 7% is how many people? Why not? People are saying no. Yeah, I have the word approximately in the question. Yep. Yeah, and I'm dealing with ratios, which describes relationships, and here I have percents, which are also a way of describing sort of relationships between parts and wholes. So I know that the associate's degrees to the some college and no degree, they're going to be in a ratio of 7 to 20. And that's going to be true when I have 196,000 people. It will be true if I had, 27 people or 100 people. There's always going to be 7 parts here to 20 parts here. So I can just directly connect the percents here. How do I now go from this to an answer? How did people do that? We've pulled the right information off our graph. Yeah, like this is similar to what we saw in the last one. I see 20 is pretty close to 21. And I know that I can divide both 7 and 21 by 3. So again, I can approximate and I get 1. Oh, not by 3, by 7. Sorry, silly error on my part. I get 1 to 3. Enter choice B. The other thing that I can do if I need to compare ratios is I could convert it. I could do that division and convert it to a decimal. I don't need to do that here, but sometimes that is useful in these. Questions about this one? Is the actual like math calculation in any of these super complicated? This is very much what you often see with data interpretation. The actual math, like the part where you're working with numbers, doesn't necessarily take that long, and it's not necessarily that hard. It's often less hard than the math you'll see in the other types of questions. A lot of times the difficulty or the tricks or the room for error here is in the graphs and in unpacking the information. So that's why we emphasize taking a lot of time up front with unpacking things, because then you trust that the calculations will go quickly. If you rush sometimes into the calculations, it ends up being less efficient. Let's do one more. Same paragraphs. Here you go. All right, go ahead and chat in your answer if you have one. Do we need to use a calculator here? Did people use a calculator here? Maria says no. What about everyone else? Tiffany did. Yeah, this one is a little, I think this one is a little less clear cut. Like if I look at the answer choices, I see they're not super, super close together, but they're not that spread out. Like I could do it without a calculator. I could estimate, but I'm not going to be able to do like a really, really loose estimation. So, all right. I look at my question and I see the really important thing here, do not hold a bachelor's or a graduate. So I'm looking for everything except these two categories. So I'm looking for all of the rest of this circle. Now, I could, in theory, find, okay, how many people are in this category and how many people are in this category and subtract it from my total. But what might be a faster way to do this? That's a lot of steps, like to figure out what's 10%, what's 17%. Okay, subtract that. Yeah, and Maria, how'd you get 70%? Yeah, yep, that's gonna save us some time here. If I say, okay, I'm going to take out the 10%, take out this, so sort of 100% minus 10% minus 17%, and I'm gonna get 73%. And then I can just find 73% or, round it to 70% of 196,305 if I'm going to use my calculator, or of 200,000 if I'm going to do some estimation. This way will put me right at my exact answer. This way will give me about 140,000. And I can go with that. So could calculate here, could estimate. I think either way, this one is one that could kind of go either way. The important thing is combine the percents first, like sort of work with the percents as long as possible, then subtract. Iman, you definitely can do it that way, sort of find 30% and then subtract that number from the whole. I prefer, it's not my personal preference because I think it adds an extra step. And to me, that's an opportunity for a small error. But if you feel like that to you is just going to be the fastest, most logical way to do it, then there's certainly nothing wrong with it. All right, questions about this one? So we are almost out of time, but before we go, I want to just quickly remind us of our process, because this process is going to help you with graph questions that are sort of easy, medium, but especially as you scale up to harder problems. Having a really consistent process is going to make things more efficient. It's going to help you be more accurate. So read the graph, break down the question, look at the answer choices, decide how you're going to approach. And then if you do a really good job of those first 3 steps, that 4th step, the actual calculation part, should go pretty smoothly. What I would like all of you to do before we leave is think for a moment about something you learned tonight that you found useful, that you want to really make sure you remember as you go out into studying, and then share that with us in the chat. This is a really good thing to do every time you study, sort of end by recapping for yourself your big takeaways from your study session. It's going to ensure that things really stick for you. So everyone think of one takeaway, big or small, out of what we've done tonight. Share it with us. Unfortunately, there isn't, Jessie. There's something that I sometimes do with graph questions is I will touch the screen or hold my paper up to it, and that helps me focus my eyes. Yeah, it is. I agree. there's definitely things about the fact with reading and with graphs that you're working off a screen that make it more difficult. Something to keep in mind as you study too, doing particularly reading comp and graph questions on a screen as opposed to in a paper book can be a good way to prepare. Yeah, I like that. ID chart type. What does it tell us? Sort of what types of calculations might be involved? What else? What are takeaways from some other folks? See if we can make a good list. Yeah, nice. Yep. That, Iman, also translates very much to reading comp. Like a similar thing will work with reading comp too. Nice. I think this is a great list. Yeah, and practicing with the more complex graphs too is helpful. All right, thank you so much for being here tonight. I wish you all the best of luck as you continue studying. We do a couple of these free prep hours every month. You can also attend the first session of any one of our classes as a free trial. There's some other good free resources on our website too. So if you want more, take a look. And I hope it all goes well and you enjoy your time in grad school. Enjoy the rest of your Sunday.